Alright, hey guys. So, in this video, we are going to deal with a problem about a rocket undergoing the forces of gravity on Earth. So, as you can see, we have a basic rocket, traveling in a parabola. So, just as a side note before we start, the rocket won't actually be traveling any distance sideways. The displacement will be zero when it reaches ground again. The shape of the parabola is just to basically help you visualize the path of travel. So here's the problem. We have this rocket, and it starts off on its launch pad with 0 meters per second velocity. And on the launch pad, we're going to have the displacement equal to 0, so let's say it's at sea level. Alright, so far so good. So in the bottom left corner, we have the displacement, which is 0, and the initial velocity, which is also 0. Now, in the question, our rocket is going to have thrusters, and they're going to create an acceleration rate of 50 meters per second squared, depending on the direction of the rocket. However, before the liftoff, nobody checked the thrusters to see if they would work properly. As the rocket launched, the thrusters turned on, and they assisted with the acceleration of the rocket, but 5 seconds after liftoff, the thrusters failed and they stopped. At this point, the rocket continued on its path and was affected by the forces of gravity like any other object in the air would. So in the bottom left corner now we have our displacement, our beginning velocity, our acceleration, and our gravity, because we are on Earth, so we're going to have that negative 9.81 meters per second squared. So as the rocket continues on the path, it eventually will reach that peak where the velocity is equal to 0. It's the highest point it's going to reach. And then 2 seconds after it reaches that highest point and begins its descent, the thrusters randomly re-engage and shoot it back towards the ground. They re-engage with the same acceleration rate as they did the first time they came on at the beginning, so it's going to be another 50 meters per second squared situation. It's going to shoot it into the ground, and they don't turn off until it hits the ground. So what we want to find out is we want to find the time between when the thrusters turned off and when the rocket reached the highest point of its travel. So not necessarily the distance between the two, but the amount of time in seconds between those 2 points. Then we want to find the height of the rocket when it reached its highest point, and then we also want to find the final velocity of the rocket when it reached the ground.
Alright, so the first thing that you want to do when you solve this, to find the time between the failure of the rocket thrusters and the point at which the velocity is equal to 0 at the top of that parabola, is you want to find the distance when the rocket thrusters failed, so the distance at 5 seconds. So to do that, we're going to use one of our distance formulas that has initial velocity, time, and acceleration, because we have all three of those variables already given to us. So once we plug that in, we're going to get a nice number of 625 meters. That's how high the rocket was in the air when the rocket thrusters failed. Now, if we want to find the time when v equals 0, or the peak of the parabola, we need to find the final velocity in order to plug in one of those equations. So the next thing I want to do is find the final velocity when the rocket thrusters failed, because from that point on, the acceleration rates are going to be different, because now it's going to be gravity acting on it instead of the rocket thrusters themselves. So you want to plug it into VF equals VI plus AT, and it's going to have an acceleration of 50 for 5 seconds, and after 5 seconds it's going to have a final velocity of 250 meters per second. So now that we have the speed at which the rocket thrusters failed and the height at which they failed, we can now try and find the time at which the rocket reached its peak. So we're going to plug in that same formula again, VF equals VI plus AT, but this time, since we're starting at the same exact location that we just ended, our final velocity, 250 meters, is going to become our initial velocity, because that's where it's starting, because we're going to end up at the top of the peak where the velocity is equal to 0. Now that the thrusters have failed, it's no longer being enacted upon with an acceleration of 50 meters per second squared. Now it's simply going to be acted upon by the forces of gravity on Earth. So next you're going to want to solve this equation for time. And when you do, you get 25.48 seconds. So we have the first answer to one of the questions, which is going to be 25.48 seconds. That's the answer to question number 1. All right, to solve the next question, which is going to be the highest point that the rocket reaches, we're going to want to start solving for total distance. So now that we know how long the rocket takes to reach the highest point after the rocket thrusters fail, we can plug in a different equation here. The d equals vi t plus 1/2 at squared formula. And for the vi, again, it's going to be 250 times the time, which is 25.48 seconds, plus 1/2 of the acceleration due to gravity times the number of seconds squared. So now once we find that, we have a distance of 3,185.52 meters. Now, this isn't the total distance, because this is just from the point where the rocket thrusters failed until that point of 0 velocity. So we have to go back and we have to add our first distance and our second distance together, and we end up with a total distance of 3,810.52 meters. That is the highest point that the rocket will reach on its destination point. Alright, so now we're going to try to find the answer to the last question, which is the final velocity of the rocket when it hits the ground. So, since this problem is kind of split up into 2 parts, where for the first portion it's only acted upon by gravity, and the second part it's acted upon by added acceleration due to the rocket thrusters, we're going to split it up into 2 parts. So to answer the first part, we want to find the final velocity of the rocket at the point where the shifters turn on, the thrusters, So we know that they turn on after 2 seconds. So we're going to find the final velocity using the VF equals VI plus AT formula. So if we set it equal to VF, we're going to have 0 plus negative 9.81 times 2 seconds. And our final velocity is going to be negative 19.62 meters per second. Now that is the final velocity at the point in which the rocket thrusters turn on. So now we need to find the final velocity when it hits the ground, but we can't do that until we know the distance left that it has to travel. So we have to find the distance that it already has traveled on the way down first. So we're going to use that d equals 1/2 VF plus VI times t formula. We're going to plug our numbers in, and we're going to get a distance of negative 19.62, because that 1/2 times 2 just cancels out. Whoa there. Alright, let's just get another sheet of paper. So now that we have that distance, we know how much distance left it has to go, and it's 3,790.9 meters. So now we're going to go back to the equation, that original equation that we were trying to do up here. So we're going to plug all our numbers in. We're going to have negative 384.94 plus 2 times negative 50 times 3,790.9. We're going to solve for it, and our final velocity will be negative 616.02 meters per second.